Well, good afternoon to everybody. My name is Hudson. As he said, I'm from Brazil, far land from here. And I'm here to talk about some works of my group in Brazil, and specifically to the works that cares to improving bioavailability of resveratrol. We have some line of researchers, and I'm here to talk about some of them. Well, first of all, I will present the site of where we work. Here it's Minas Gerais state in Brazil, and we are here. So here are some pictures of our university, and we are there. So the Faculty of Pharmacy. Among these faculty, we actually have 50 students, and we work together with the Faculty of Medicine. So we have a post-graduation that works together in this field. So talking about specifically of resveratrol, it's a really remarkable molecule for many pharmaceuticals. We have lots of promises with this molecule. As you can see about with the pictures, it is found in great amounts in grapes, of course in the wines of these red grapes. So the story of you drinking wine, it really works because it contains resveratrol. So, but it has a great dilemma. It has a great biological activity, but it has a problem with bioavailability. So which activities are we talking about? We're talking about huge antioxidant activity, anti-photoaging, neuroprotective, antiviral, photoprotection, and this photoprotection we researched in our team. And he has also antiviral. Recently, I read a paper that they discovered some activity against HIV, so it's a quite big deal. And prevention of heart diseases, as we know about the wines. But we have the problem of the oral viability. Nearly 10% of all we consume, it's bioavailable. All the rest is lost when we have oral route because it's extensively metabolized in the liver. So thinking of that, we thought that we had a great molecule in our hands, but we had some problems to solve. So we have some research lines that we work with transdermal routes. So this was the first thing that we thought about. It was the transdermal route. So we studied that, and we have two recently published articles with that. The first one dealing more with the analytical aspects of this, and the other with the skin permeation, although the first one has already previous data on this. So this is just to show the method. It's an HPLC with UV detection, so it's quite simple for all we here. We achieved this method using CCD, the optimizing method. So we achieved that. Here is another simple that everybody's used here. The receptor media for transvertical diffusion cells that we used. This is just to illustrate that we always test this media. It's PBS, everybody tests PBS, but also simulated human sweat and simulated body fluid. But here for the resveratrol, simulated human sweat was the best. It was quite surprising because its aqueous solubility was very poor. And so here's first data on permeation. We have the in vitro release and the ex vivo percutaneous permeation. And here we have to say that we used we used a cream a quite simple cream. It's a pluronic organogel, lecithin organogel. We developed that in a partnership with a company, a Dutch company named Fora, and so the cream has a composition that it's quite simple to reproduce in other laboratories, in compounding pharmacies worldwide. And so the release, it's kind of really high. It's the left bar. And in the permeation, it's obviously lower than the in vitro release, but it achieves kind of 6 micrograms per square root of skin. Sorry. And here we proceed with the skin retention. We didn't use the tape stripping technique that it's most commonly used. We used the microtome technique. We froze the skin and performed cuts with this microtome. And so we saw that a huge amount was retained. Here we have what we found in the mucosa and what we find in the receptor medium. So as we can see, the majority of the compound was retained within the mucosa. And this was very important for us because on the contrary of the transdermal route that we wanted the resveratrol achieve the blood circulation, here we want that it's retained within the mucosa to treat the mucosa problem. And so we tested 2 formulations, and we saw the second formulations with much more polymers worked better than the first one. And so we tested also the vaginal cream. We tested 2 formulations. This was again a cream with the same composition of the cream that we tested for transdermal, and we saw that actually the amount released vaginally speaking was greater than on the skin. This was obviously expected of us because the stratocorneum of the mucosa there, it's much thinner, and this was quite good because although the permeation was good, a certain amount was also retained in the mucosa. So we have a local and a systemic effect. Here we also tested 2 formulations with the same composition, only changing the amount of the compounds. And finally, but not least, as you can see, we like this molecule a lot because we test many things with that. I forgot to say that this article with vaginal is already in press. And this, the nanotechnology results, the article is under review, so we cannot say that it will be published in the journal we submitted. But anyways, here we tested with SLN, so solid lipid nanoparticles. These solid lipid nanoparticles, the lipid fraction was made with Theobroma grandifolium, as we know as açaí. In Brazil, we have a lot of that in Amazonian forest. And in this, we also tested, as we saw, that the permeation was really good using a simple cream. Now we wanted to make SLN with a great diameter to see if it's attached to the pores of the skin for treating capillary problems. And actually we saw that it releases here in purple. Okay. In the screen, this is purple and this is blue. Okay. The first one is purple. We saw that it's the standard, it's a solution of resveratrol, and it releases very fast. But here we wanted that it releases slower for treating some capillary problems, and we saw that we can delay this release using the solid lipid nanoparticles. So it was very brief explanation of what we do. I expect if you have some questions, I will put my email here. You can send to me. We can talk after. But I hope you all get the idea of what we are doing in Brazil. So thank you.
Thank you. Wait, just a minute, just 1 minute.
Oh, okay.
Any specific question? Yes.
Yeah. Actually, it's by HPLC with UV detection, but we changed when we change the composition of mobile phase, the chromatographic conditions, so you can see, you can separate the things. Okay. Actually, we cut the round discs of mucosa. Then we put in a ultra-thorax. Then we put in a ultrasound, in a needle ultrasound. Then we filter 3 times, and then we read it. That's it.
Okay.
Okay.
Thank you very much.